Dear students, welcome to online class. Today we discuss about very interesting chapter, matter in our surroundings. In this chapter, we shall learn about matter based on its physical properties. As we look at our surroundings, we see a large varieties of things with different size, shape and textures. Everything in this universe is made up of a material which scientists have named as a matter. For example, stone, animals, small drop of water, etc. Everything is matter. Those are all the things are occupy space and have certain mass. Or in other words, they have both mass and volume. Early Indian philosophers classified matter in the form of 5 basic elements. One is air, and second one is earth, third one is fire, fourth one is sky, and lastly water. According to those scientists, every living or non-living things was made up of these 5 basic elements. But the modern day scientists have evolved 2 types of classification of matters based on their physical properties and chemical properties or chemical nature. Then coming to the topic, physical nature of matter. Matter is made up of particles ಅನ್ನೋದಕ್ಕೆ ಈ ಮುಂದಿನ ವಿಡಿಯೋದಲ್ಲಿ ಇನ್ ಡೀಟೇಲ್ ಆಗಿದ್ದಾರೆ, ಗಮನವಿಟ್ಟು ಕೇಳಿದ್ದನ್ನು. ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್ ನಂಬರ್ 1. ಈ ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್ ನಮ್ಮಲ್ಲಿ ಮ್ಯಾಟರ್ನಲ್ಲಿ ಪಾರ್ಟಿಕಲ್ಸ್ ಇದ್ದಾವೆ. ಆ ಪಾರ್ಟಿಕಲ್ಸಿಂದ ಮ್ಯಾಟರ್ ಆಗಿದೆ. ಆ ಪಾರ್ಟಿಕಲ್ಸ್ ನಡುವೆ ಸ್ಪೇಸ್ ಇದೆ ಅನ್ನೋದನ್ನ ಹೇಗೆ ತಿಳ್ಕೊಬೋದು ಅಂತ ಈ ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್ನಲ್ಲಿ ನಾವು ನೋಡೋಣ. ಒಂದು ಬೀಕರ್ ತಗೊತೀವಿ. ಒಂದು ಬೀಕರ್ಗೆ ವಾಟರ್ನ ಫಿಲ್ ಮಾಡ್ತೀವಿ. ಫಿಲ್ ಮಾಡಿಬಿಟ್ಟು ಅದಕ್ಕೆ ಮಾರ್ಕ್ ಮಾಡ್ತೀವಿ. ಆ ವಾಟರ್ ಇರುವಷ್ಟು ಸ್ಪೇಸ್ಗೆ ನಾವು ಮಾರ್ಕ್ ಮಾಡಾದ್ಮೇಲೆ ಸಾಲ್ಟ್ನ ಆ್ಯಡ್ ಮಾಡ್ತಾ ಹೋಗ್ತೀವಿ. ಸ್ವಲ್ಪನೇ ಆ್ಯಡ್ ಮಾಡ್ತಾ ಹೋಗ್ತೀವಿ. ಅದು ಸಾಲ್ಟು ಡಿಸಾಲ್ವ್ ಆಗ್ತಾ ಹೋಗುತ್ತೆ. ನಮಗೇನು, ನಾವು ಸಾಲ್ಟ್ನ ಆ್ಯಡ್ ಮಾಡ್ತಾ ಇದ್ದೀವಿ, ವಾಟರ್ ಲೆವೆಲ್ಲು ಜಾಸ್ತಿ ಆಗಬೇಕು, ಹೌದಲ್ವಾ? ವಾಟರ್ ಲೆವೆಲ್ಲು ಜಾಸ್ತಿ ಆಗ್ತಾ ಇಲ್ಲ. ಈ ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್ನಲ್ಲಿ ಬಂದು ಸಾಲ್ಟ್ ಆಗ್ತಾ ವಾಟರ್ ಲೆವೆಲ್ಲು ಇನ್ಕ್ರೀಸ್ ಆಗ್ತಾ ಹೋಗಲ್ಲ, ಯಾಕೆಂದರೆ ಅದು ಡಿಸಾಲ್ವ್ ಆಗ್ತಾ ಹೋಗುತ್ತೆ. ಅಂದರೆ ವಾಟರ್ನಲ್ಲಿ ಡೆನ್ಸಿಟಿ ಕಡಿಮೆ ಇತ್ತು, ನಾವು ಸಾಲ್ಟ್ನ ಆ್ಯಡ್ ಮಾಡ್ತಾ ಡೆನ್ಸಿಟಿ ಜಾಸ್ತಿ ಆಯಿತು. ಇದರಿಂದಾಗಿ ವಾಟರ್ ಲೆವೆಲ್ಲು ಇನ್ಕ್ರೀಸ್ ಆಗಲಿಲ್ಲ. ಎಷ್ಟಿತ್ತು ವಾಟರ್ ಲೆವೆಲ್ಲು ಅಷ್ಟೇ ಇತ್ತು, ಆದರೆ ಸಾಲ್ಟ್ ಆಗ್ತಾ ವಾಟರ್ ಲೆವೆಲ್ಲು ಅಷ್ಟೇ ಇತ್ತು. ಇದರಿಂದ ಏನು ಗೊತ್ತಾಗುತ್ತೆ ಅಂತಂದರೆ ವಾಟರ್ನಲ್ಲಿ ಪಾರ್ಟಿಕಲ್ಸು, ಅಂದರೆ ನಾವು ಗಮನಿಸ್ದಂಗೆ ವಾಟರ್ ಬಂದು ಲಿಕ್ವಿಡು. ಸಾಲಿಡ್ ಸಬ್ಸ್ಟೆನ್ಸ್ಗಿನ್ನ ಲಿಕ್ವಿಡ್ ಸಬ್ಸ್ಟೆನ್ಸ್ನಲ್ಲಿ ಪಾರ್ಟಿಕಲ್ಸು ಸ್ವಲ್ಪ ಬೀಳವಾಗಿ, ಅಂದರೆ ದೂರ ಅರೇಂಜ್ ಆಗಿರ್ತವೆ ಅನ್ನೋದು ಈ ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್ನಲ್ಲಿ ಗೊತ್ತಾಯಿತು. ಅಂದರೆ ಪಾರ್ಟಿಕಲ್ಸು.
Characteristics of particles of matter. Take 50 milliliter of water in a beaker. Mark the level of water in the beaker. Now add some salt to the beaker and stir it well with the help of a glass rod. Observe the level of water now. Add some more salt and repeat the above procedure. It was observed that the particles of salt were evenly distributed in water. Also, it was observed that the presence of salt particles did not change the level of water in the beaker. This could be possible only if the particles of salt were accommodated in between the water particles. Thus, this clearly demonstrates that space exists between water particles.
ಟೆಂಪರೇಚರ್ ಇನ್ಕ್ರೀಸ್ ಆದರೆ ಪಾರ್ಟಿಕಲ್ಸು ಫಾಸ್ಟಾಗಿ ಮೂವ್ ಆಗ್ತವೆ ಅಂತ. ಇದೇನು ಸದ್ಯ, ಟೆಂಪ್ರೇಚರ್ ಇನ್ಕ್ರೀಸ್ ಆದರೆ ಪಾರ್ಟಿಕಲ್ಸ್ಗೂ ಟೆಂಪ್ರೇಚರ್ಗೂ ಏನು ಸಂಬಂಧ ಅಂತ ಪ್ರಶ್ನೆ ಕೇಳ್ಬೋದು ನೀವು. ಏಕೆಂತಂದರೆ ಸಂಬಂಧ ಇದೆ, ಹೌದು. ಹೇಗೆ ಅಂದರೆ, ಈಗ ನಿಮ್ಮಮ್ಮ ಅಡುಗೆ ಮಾಡಿರ್ತಾರೆ, ನೀವು ಸ್ಮೆಲ್ ಮಾಡ್ತೀರಿ, ಹೌದಲ್ವಾ? ಹಾಗಾದರೆ ನಿಮ್ಮಮ್ಮ ಅಡುಗೆ ಮಾಡಿಲ್ಲ ಅಂದರೆ ಸ್ಮೆಲ್ ಗೊತ್ತಾಗ್ತಿಲ್ಲ, ಅಡುಗೆ ಮಾಡಿತ್ತು ಅಂತ ಸ್ಮೆಲ್ ಗೊತ್ತಾಯಿತು. ಇದಕ್ಕೂ ಏನು ಸಂಬಂಧ ಅಂತಂದರೆ, ನಿಮ್ಮಮ್ಮ ಅಡುಗೆ ಮಾಡ್ತಿರುತ್ತೆ, ಅಂದರೆ ಟೆಂಪ್ರೇಚರ್ ರೈಸ್ ಆಗಿರುತ್ತೆ. ಟೆಂಪ್ರೇಚರ್ ರೈಸ್ ಆದಂಗೆ ಪಾರ್ಟಿಕಲ್ಸ್ ಮೂಮೆಂಟು ಫಾಸ್ಟ್ ಆಗ್ತಾ ಹೋಗುತ್ತೆ. ಆ ಪಾರ್ಟಿಕಲ್ಸ್ ಮೂಮೆಂಟ್ ಫಾಸ್ಟ್ ಆಗ್ತಾ ಹೋದಾಗ ನೀವು ಸ್ಮೆಲ್ ಮಾಡ್ತಿರೋದ, ಹೌದಲ್ವಾ? ಇದರಿಂದ ಗೊತ್ತಾಗುತ್ತೆ ಪಾರ್ಟಿಕಲ್ಸು ಟೆಂಪ್ರೇಚರ್ ರೈಸ್ ಆದರೆ ಫಾಸ್ಟಾಗಿ ಮೂವ್ ಆಗ್ತವೆ ಅಂತ ಗೊತ್ತಾಗುತ್ತೆ.
We know that there is a lot of space present between the particles of matter. Particles of matter are never at rest and keep moving continuously in these free spaces. Although their movements are not visible to the naked eye, it can be proved through the following activity. Take some incense sticks and smell their fragrance. Now place them at a distance from yourself and try to smell them. You will be able to smell the fragrance of the unlit incense sticks when you are close to them. However, their fragrance will not reach you when you are at a distance from them. After this, light the incense sticks and try smelling their fragrance from a distance. However, when the incense sticks are lit, you will be able to smell their fragrance even from a distance. Hence, it can be concluded that particles of matter move continuously and their speed increases with an increase in temperature.
ಈ ಮೂರನೇ ವಿಡಿಯೋ ಬಂದು ಅಂದರೆ ಮೂರನೇ ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್ ಬಂದು ಪಾರ್ಟಿಕಲ್ಸ್ ಒಂದೊಂದು ಸಬ್ಸ್ಟೆನ್ಸ್ನಲ್ಲೂ ಒಂದೊಂದು ಮ್ಯಾಟರ್ನಲ್ಲೂ ಒಂದೊಂದು ಥರ ಬೇರೆ ಬೇರೆ ಥರ ಅರೇಂಜ್ಮೆಂಟ್ ಆಗಿದೆ. ಹೇಗೆ ಅಂದರೆ ಈಗ ಸಪೋಸ್ ಈ ಒಂದು ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್ನಲ್ಲಿ ಒಂದು ಐರನ್ ರಾಡ್ ತೊಗೊತಾರೆ, ಇನ್ನೊಂದು ಚಾಕ್ ಪೀಸ್ನ ತೊಗೊತಾರೆ. ಅದನ್ನ ಅವೆರಡನ್ನೂ ಹ್ಯಾಮರಿಂದ ಬೀಟ್ ಮಾಡ್ತಾರೆ. ಬೀಟ್ ಮಾಡಿದಾಗ ಐರನ್ನು ಹೇಗಿತ್ತು ಹಾಗೇ ಇರುತ್ತೆ. ಯಾಕೆಂದರೆ ಐರನ್ನಲ್ಲಿ ಪಾರ್ಟಿಕಲ್ಸು ಅರೇಂಜ್ಮೆಂಟ್ ಆಫ್ ಪಾರ್ಟಿಕಲ್ಸು ತುಂಬ ಸ್ಟ್ರಾಂಗ್ ಆಗಿರುತ್ತೆ. ಅದೇ ನಾವು ಚಾಕ್ ಪೀಸ್ನಲ್ಲಿ ಬರುವಂತಹ ಪಾರ್ಟಿಕಲ್ಸ್ನ ನಾವು ಬೀಟ್ ಮಾಡಿದಾಗ ಚಾಕ್ ಪೀಸ್ನ ಬೀಟ್ ಮಾಡಿದಾಗ ಚಾಕ್ ಪೀಸು ಬ್ರೇಕ್ ಆಗುತ್ತೆ. ಇದರಿಂದ ಗೊತ್ತಾಗುತ್ತೆ ಒಂದೊಂದು ಸಬ್ಸ್ಟೆನ್ಸ್ನಲ್ಲೂ ಅರೇಂಜ್ಮೆಂಟ್ ಆಫ್ ಪಾರ್ಟಿಕಲ್ಸ್ ಈಸ್ ಡಿಫ್ರೆಂಟ್. ಈ ಚಾಕ್ ಪೀಸ್ನಲ್ಲಿರುವಂತಹ ಪಾರ್ಟಿಕಲ್ಸ್ಗೆ ನಾವು ಕಂಪೇರ್ ಮಾಡಿದ್ರೆ ಐರನ್ನಲ್ಲಿರುವಂತಹ ಪಾರ್ಟಿಕಲ್ಸು ತುಂಬ ಸ್ಟ್ರಾಂಗ್ ಆಗಿ ಅರೇಂಜ್ ಆಗಿರುತ್ತೆ ಅನ್ನೋದು ಗೊತ್ತಾಗುತ್ತೆ. ಫೋರ್ಸ್ ಆಫ್ ಅಟ್ರಾಕ್ಷನ್ ಒಂದೊಂದು ಆಬ್ಜೆಕ್ಟ್ನಲ್ಲೂ ಬೇರೆ ಬೇರೆ ಥರ ಇರುತ್ತೆ ಅನ್ನೋದು ಈ ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್ನಿಂದ ನಾವು ತಿಳ್ಕೊತೀವಿ.
Take an iron ball and a piece of a chalk. Try to break the iron ball by hammering it. Repeat the process with the chalk piece. You will observe that the chalk piece breaks easily, but the iron ball does not break. This is because the forces of attraction between the chalk particles are lesser than the iron particles. Iron particles attract each other with a much greater force. This makes iron very hard and strong, because of which the iron ball does not break. Therefore, on the basis of the above activity, we conclude that the particles of matter attract each other. However, this force of attraction varies from matter to matter.
ಓಕೆ, ಪಾರ್ಟಿಕಲ್ಸ್ ಮ್ಯಾಟರ್ನಲ್ಲಿ ಹೇಗಿರುತ್ತೆ, ಫೋರ್ಸ್ ಆಫ್ ಅಟ್ರಾಕ್ಷನ್ ಹೇಗಿರುತ್ತೆ, ಹಾಗೆ ಟೆಂಪ್ರೇಚರ್ ಜೊತೆ ಹೇಗೆ ರಿಯಾಕ್ಟ್ ಆಗುತ್ತೆ ಅಂತ ತಿಳ್ಕೊಂಡ್ವಿ. ನೆಕ್ಸ್ಟ್ ಬಂದು ಹೌ ಸ್ಮಾಲ್ ಆರ್ ದೀಸ್ ಪಾರ್ಟಿಕಲ್ಸ್ ಆಫ್ ಮ್ಯಾಟರ್ ಅಂತಲೇ ಕೇಳ್ಬೋದು. ಇದಕ್ಕೂ ಒಂದು ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್ ಇದೆ, ಬನ್ನಿ ನೋಡೋಣ.
Here, let us perform an activity to note how small are the particles of a matter are. Click each tab to know more. Take a beaker. Fill it with water. Now take potassium permanganate. Add some crystals of potassium permanganate in a beaker. Now, take out approximately 10 ml of this solution and add it to 90 ml of clear water in another beaker. Once again, take out 10 ml of this solution and add to another 90 ml of clear water. Carry out this process 3 or 4 times and observe changes in the color of the solution. We observe that the solution remains colored even when highly diluted, but the color of the solutions decreases with dilution. Finally, we conclude that there must be several tiny particles in just one crystal of potassium permanganate which get uniformly distributed in water to change its color.
ಏನಾಯಿತು, ಕಲರ್ ಕಾಂಬಿನೇಷನ್ನು ಬರ್ತಾ ಬರ್ತಾ ಕಡಿಮೆ ಆಯಿತು. ಪೊಟ್ಯಾಷಿಯಂ ಪರ್ಮಾಂಗನೇಟ್ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಕಡಿಮೆ ಆದ್ರಿಂದ ಕಲರ್ ಕಾಂಬಿನೇಷನ್ನು ಕಡಿಮೆ ಆಯಿತು, ಹೌದಲ್ವಾ? States of matter. We know so many types of matter around. ಹಾಗಾದ್ರೆ what are its different states? ಮೊದಲನೇದು solids, ಎರಡನೇದು liquids, ಮೂರನೇದು gases. These states of matter is arises due to the variation of alignment of these particles. Now let us study about the properties of the three states of matters. The solids, example, pen, ball, book, etc. These are all have a definite shape and distinct boundary and fixed volume. Solids may break under the force, but it is difficult to change their shape. So they are rigid. Haudalva? And those substances are called rigid substances or rigid bodies. Liquid state, oil, milk, water. Those are all examples for liquid. Those are all not have a definite shape, but it have a fixed volume. Liquids are flow easily. Solid, liquid and gases are diffuse in liquids. The rate of diffusion of the liquids is greater than that of the solids.
You all know that matter is what things are made of and that it possesses two fundamental properties. It has mass, which is the quantity of matter that it has, and volume, which is the space it occupies. Well, today we're going to learn about the states that matter can be in. Matter can be in three states: solid form, liquid form, and gas form. Each one of these has its own characteristics. Let's get to know them. Solid state is characterized by having a fixed volume and size. Although, in some cases, we can change its size, like with plasticine or clay. In these cases, they are malleable solids. Liquid state is characterized by having a fixed volume and variable size. Liquids take the container's shape, like this glass or jug. Gas state is characterized by having a variable volume and size. In the same way that liquids take the shape of the container holding them, but gases always occupy the full volume of the container. Now we know about the three states of matter.
ಹಾಗಾದ್ರೆ can matter change its state?
Do you know how we can change from one state to another?
The state of matter is interconvertible. This convertible is possible either change in pressure or temperature. There are three different states of matter. Here, first one is solid, liquid, gas.
Changes in state happen after cooling or heating matter, and there are different types.
Here, solidification is a process. Liquid is converted into solid. It's called solidification. Fusion is a process. Solid substance is converted into liquid. That's called fusion. And vaporization. A liquid is converted into gas. And condensation. This gas is converted into liquid. Very important thing is sublimation. Sublimation is a process change of state from gas to solids or vice versa, solid to gas without going in a liquid state is called sublimation. It's a very important thing. Effect on temperature on particles. Temperature increases as the kinetic energy of a particle is also increases. As a result, particle vibrating at high speed, particles leave their fixed position. ಅಂದರೆ ಪಾರ್ಟಿಕಲ್ಸು ರೆಸ್ಟಲ್ಲಿ ಇದ್ದ ಪಾರ್ಟಿಕಲ್ಸು ಟೆಂಪ್ರೇಚರ್ ಕೊಟ್ಟಿಗೆ ಮುಂದಕ್ಕೆ ಮೂವ್ ಆಗ್ತವೆ. ಆಸ್ ಎ ರಿಸಲ್ಟ್ ಪಾರ್ಟಿಕಲ್ಸ್ ಮೂವ್ ಫ್ರೀಲಿ.
Melting, solidification, evaporation, and condensation. Melting happens when matter changes from its solid to liquid form and happens after rising temperature. When we heat an ice cube or leave it at room temperature, it melts and changes from solid to liquid. Solidification is the opposite from melting. Matter changes from liquid to solid form. It happens when we put water in the freezer and it turns into ice. It goes from liquid to solid. Evaporation is when matter changes from liquid to gas. After liquids are heated, for example, when we boil water, it turns into water vapor. It turns from liquid to gas. Condensation is a step from gas to liquid and happens when matter in gas state is cooled. Have you ever noticed that when we get steamy windows or mirrors, water droplets appear? It's produced when water vapor touches a cold surface. In that same moment, water vapor cools and turns into liquid. Easy, huh?
Let us see some interesting properties of the matter in different states. We will start with an empty syringe. We will put some chalk pieces in it and press the piston harder. You would see the piston, after muscle force, the chalk pieces are allowed to break down. They break down in small pieces in a powdered form. You would see how these powdered pieces are being put back in the syringe. Repeat the same for the liquids. We will close the nozzle and pour a colored liquid in a syringe. Close it down with the syringe piston and press it to remove the air from the volume of the syringe. We will see the liquid takes the shape of the syringe. Now we will do it for the gas using the smoke of the incense stick. Put the piston and cover the mouth of the syringe with the tip of your finger. We will start using the stoppers to close the mouth of every syringe. We can see for the solid, liquid and gas, we have provided a stopper. Now we compress it harder to see whether the change of the chalk powder are compressed. We can't see any. The liquids, can it be compressed? It can't do the same. But in the gases, you see it can be compressed better than solids and liquids. You can provide extra force to see how dense the gases can be seen in the syringe. What we learn here is solids have a regular shape and closely packed molecules which doesn't allow us to compress further. Liquids have loosely packed molecules which allows little to compress, but here you can't see with the muscle power. But in the case of gases, the molecules move in all directions at faster speed with large interspacing.
So what is the effect of temperature on the particles? The increased heat energy due to the rise in temperature increases the kinetic energy in solids. This increase results in particles vibrating at higher speed. The energy supplied by heat overcomes the force of attraction between the particles. The particles leave their fixed position as seen here and start move more freely. A stage is reached when the solid melts and is converted into a liquid. Same way, if more energy is given to the liquid, they tend to move more freely and are converted into a gaseous state. The reverse process occurred when gas is converted to liquid and liquid to solid by decreasing the temperature or removing the heat. The temperature at which a solid melts to become a liquid at the atmospheric pressure is called its melting point. The amount of heat energy that is required to change 1 kg of a solid into a liquid at atmospheric pressure at its melting point is known as the latent heat of fusion. Because of this latent heat of fusion, the particles in water at 0 degree centigrade do have more energy as compared to the same particles of ice at the 0 degree temperature. The next thing is the boiling point. The temperature at which a liquid starts boiling at the atmospheric pressure is known as its boiling point. Latent heat of vaporization is the heat energy required to change 1 kg of a liquid to gas at its atmospheric pressure at its boiling point. This makes the particle in steam, that is water vapor, at 100 degrees centigrade to have more energy than the water at the same temperature. So what is the effect of pressure on states? Gases are converted to liquid for easy transportation. Now this conversion is possible by decreasing the temperature and increasing the pressure. This process is also known as liquefaction. Dry ice or carbon dioxide is converted into solid state under a very high pressure. Solid carbon dioxide get converted directly to gaseous state on decrease of pressure to 1 atmosphere without coming into liquid state. And that's the reason why solid carbon dioxide is also known as dry ice. So what is the difference between boiling and an evaporation? Boiling is a bulk phenomena. Particles from whole of liquid, let's say some water is getting boiling, so particles from whole of liquid can change into a vapor state. On the other hand, evaporation is a surface phenomena. Particles from surface only gain energy to convert into a vapor state. So what are the factors affecting the evaporation? The factors affecting the evaporations are: the first one, an increase in the surface area. We already talked about that evaporation is a surface phenomena. If the surface area is increased, the rate of evaporation increases. For example, while putting clothes for drying up, we spread them out. An increase in temperature. With the increase in temperature, more number of particles get enough kinetic energy to go into the vapor state. Therefore, an increase in temperature would increase the rate of evaporation. The decrease in humidity. Humidity is an amount of water present in air. The air around us cannot hold more than an infinite amount of water vapor at a given temperature. If the amount of water in air is already high, the rate of evaporation decreases. An increase in wind speed. It is common observation that clothes dry faster on a windy day. With the increase in wind speed, the particles of water vapor move away with the wind, decreasing the amount of water vapor in the surrounding. Thus, the rate of evaporation will increase.
Matter. Since early times, human beings have been trying to understand their surroundings. As we look at our surroundings, we see a large variety of things with different shapes, sizes, and textures. Everything in this universe that we see is made up of material, which is called matter. Matter occupies space and has mass. All matter is made up of tiny particles. If we were to observe sunlight falling through a window, we would be able to see tiny particles floating in the air. These particles have spaces between them. Let's demonstrate that using the example of salt dissolved in water. When we dissolve salt in water, the particles of salt get into the space between the particles of water. Also, you will observe that there is no change in the water level. Thus, we have found that particles have space between them. You will also see that the particles continuously move. A drop of ink slowly spreads in water. Matter around us exists in 3 states: solid, liquid, and gaseous. Matter in the solid state has definite shape and volume. This is because the particles in solid are tightly packed, fit together in a regular way, and there is no big space between the particles. Therefore, The force of attraction between the particles is very strong, and the only movement they make are tiny vibrations to and fro. That is why solids are rigid and retain their shape. If we take a stone and put it in a box, the pebble retains its shape. Matter in liquid state has no fixed shape but has a fixed volume. In liquids, the particles are most closely held together but are not in a fixed pattern. Particles move freely and have greater space between each other. Because of the greater space between the particles, the force of attraction between the particles is weaker than in the solid. Matter in gaseous state has no definite shape and no definite volume. In the gaseous state, the particles are far apart. There is a lot of space between the particles and they move about randomly at high speeds. Due to the huge space between the particles, there is no force of attraction. When a stone is dropped into a beaker with water, why does the stone sink into the water? Let us explore. Generally, the density of solid is high compared to liquid and gas because there are not big spaces between the particles. Gases have much lower densities than either liquids or solids. Let us examine compressibility, another attribute of matter. These are empty syringes. Close the nozzles of the syringes with rubber corks. Fill one syringe with chalk pieces, fill another with water, and leave one syringe empty. Insert the piston and try to compress the material in the syringe. You will see that the syringe with the solids is not compressible because the solids are rigid. The syringe with water is compressible because there is greater space between particles compared to solids. The syringe which is empty is easily compressible because the particles in a gas, in this case the air in the syringe, have more space than solids and liquids. This experiment shows that gas is highly compressible compared to solids and liquids. Yet another attribute which differentiates solids, liquids and gases is diffusion. When perfume is released into the air, the fragrance spreads very fast. This is due to the movement at high speed of particles and the large space between them, thereby gases show the property of very fast diffusion. Liquids have less diffusion when compared to gas. In solids, diffusion is negligible. Things to remember. Matter exists in three states: solid, liquid and gaseous. Solids have definite shape and volume, liquids have no fixed shape but have a fixed volume, gases have no definite shape and volume. The spaces in between the constituent particles are minimum in the case of solids, intermediate in liquids and maximum in gases. The forces of attraction between the particles are maximum in solids, intermediate in liquids and minimum in gases. Generally, density is very high for solids, moderate for liquids and much lower for gases. Generally, compressibility and diffusion are negligible in solids, moderate in liquids and very high in gases.